Hey everyone, Chang here and welcome to my channel. Now, for today we're going to go over a super basic concept, and should serve as like a refresher for those of you guys who have seen it before or learned it quite a while ago, or if it's new, hopefully this is a good intro to the topic. Now, we're talking about probability. I mean, it only makes sense. We went through all the different possible way of counting, so to combine it all together and utilize it so that it is efficient, good for understanding, the next concept, of course, is to use it in probability. Now, what is probability? Well, the basic concept of probability is very simple, right? It is just basically your desired outcome, so what you want to happen, over all possible outcome. So as you can see there, that's why there is a certain counting element to it, but maybe not nearly as severe. Now, we have our desired outcome over all possible outcome. That is it. That is the whole concept, the whole nutshell of probability. Of course, you have a lot of those special cases, intricately designed a problem where basically trying to find the number of desired outcome or the possibility, all the possible outcome is what makes it complicated. The concept of probability itself, it's not. So this one is fairly simple. You flip a fair coin. Now, every time you look at a problem, be very careful to see that they say fair dice, whatsoever, because every now and then they will throw a problem in there where it's not fair, is skewed in some way. I don't know, maybe the coin is weighted more on one side or the other, or the dice is loaded, right? We have situations like that. So always pay attention to see if they say fair coin or fair dice. If they do, then you know that each and every possibility is of equal chance and yada, yada, yada. You guys know the rest. All right, so fair coin. That means you have the probability of two options. You have your head and then you have your tail, right? Our desired outcome based on the problem itself is what's the probability of head. Our desired, or of tail actually. Our desired outcome is tail. So that's 1, right? Out of 2, there's only 1 that we want. How many possible outcome? 2. And just like that, the probability of you getting tail when you flip a fair coin is 1/2. Or often they would say 50%. Now, I'm a little worried about the whole 50% thing. If you guys haven't seen my video on percentage, definitely check it out. This can be misleading. I like this one better because it actually demonstrates there's only 2 possibility and the desired outcome is that 1 possibility. So there's a fairly simple example. Let's look at some other. Now, as problems get more and more complicated, once again, probability, desired outcome over all possible outcome. That's all it is. So we're looking at this. Rolling 2 standard fair dice. Standard, in this case, when they're talking about dice, is the standard 6-head or 6-sided dice, right? Now, there are other dices, of course. If you play Dungeons and Dragons and all that other stuff, there's a bunch of myriads of different side dice. But when they say standard, assume 6. 2 of them and they're fair. So it's not loaded in any way. You have equal chance of rolling any one of those face. Now, what is the probability that the sum equals 5, right? The sum equaling 5. All right, so basically you're rolling 2 dice. Your desired outcome is that the result actually adds up to become 5, right? Out of all of that, we want to find the also all possible outcome and then figure out the probability. Well, what could occur to make it add up to 5? You have your standard, I'm just going to write it as a pair, 1, 4, right? The first dice is 1, the second dice or last dice is 4, right? We have the other possibility, the first dice is 4, and the last dice is 1, right? That's 2 different possibilities. Well, what else? We have the 2, and then 3, and then 2. Anything else? I think that's it. There it is, right? That's the only possible way 2 standard fair dice, when you roll it, can add up to become 5. Cool. So there's 4. 4 is going to be on top of our fraction. This is our desired outcome. Now, the total possible outcome is fairly simple, right? Remember, the first dice you have the possibility of 1, 2, 3, 4, 5. and 6. Second dice is the same thing. 1, 2, 3, 4, 5, 6. And if you watch my video or you have prior knowledge and you know exactly how to find all the possible combinations, right, or permutations, then you're good to go, right? If not, well, you can always just write it out and then start counting. 1, 2, 3, 4, 5, 6, and then you keep going. 1, 2, 3, 4, 5, 6, and you can sort of guess at this point, right? This one has 6, this one has 6, and then on and on. So basically the bottom is going to be 6 times 6, or in other words, 36. So you have 4 over 36, or if you wanted to simplify it, 1 over 9, or if you want to go even further, which I'm not going to do here, right? You can actually convert this to decimal and then to percentage or whatsoever, whichever form works best for you, right? I prefer personally this because it talks about the actual, possible outcomes and the desired outcome. This is okay as well. I mean, it gives you a ratio, and then of course you have your percentage, and you know how I feel about percentage. All right, let's look at this one right here. As you can see, with more and more examples, I'm hoping that you can see where a lot of the different counting techniques come in, whether permutation, combination, so on and so forth, right? So let's look at this one. We have positive integers up to and equal to 100. What is the probability of selecting a number divisible by 10? What is our desired outcome? Well, any number that's divisible by 10. And in this case, they're all positive integers. So since it's positive, 0 doesn't count, right? And everything, well, we know what positives is, right? So we have 10, right? That's divisible by 10, clearly. Then we have 20, and we can go on, 30, 40, 50, 60, 70, 80, 90, and of course 100, right? Because it is up to and equal 100. There we go, right? So this is all of our desired outcome. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's simple. So in our fraction, 10 on top. Well, positive integers, all the possible positive integers up to and equal to 100. Well, that's 1 all the way to 100. So that should be fairly simple. Right here, we have 100. And just like that, that is our probability. Of course, once again, if you want, that's 1 over 10, right? If you simplify it. And of course, if you really want, that's 0.1 as a decimal. You can easily do that, or 10%. Any one of these work. Take your pick. Alright, so as I mentioned, probability is easy. The problem itself might not be so much if it's difficult to understand. So let's look at this one. You have the word abra, A-B-R-A. The letters are rearranged to all possibility. What is the probability of selecting words with double A? Now when I first saw this, I was like, what the hell does that mean, double A? Basically, it means that the two letters are right next to each other. So what's the probability of selecting words such that the two A's are immediately next to each other? So first and foremost, the two A immediately next to each other, that is our desired outcome. So how can we come up with a way to get that? That's where it's interesting, right? If we're looking at it, no matter what, out of all the possibility, we want to make sure the A's are right next to each other, right? So no matter what, we want the A's, and then we have the B and then the R. So notice I wrote the A's immediately right next to each other. So the way we want to rearrange it, to organize it, is actually only 3 different combinations, right? We have our double A, and we have our B and R, and then we can put it whichever way, but we don't want to separate this. So normally when you have 4 letters and you want to find ways to rearrange the 4th thing, we would go with 4 factorial. But in this case, we're not going with 4 factorial, we're going with 3 factorial, right? So the top part of the fraction is going to be 3 factorial. Or if you really want to just write it out, 3 times 2 times 1, or just 6. That's the top part of the fraction, right? The bottom part is a little tricky, right? We're looking at all the possible ways to rearrange these 4 letters. Now here's the key though. The 2 A's are technically interchangeable. It doesn't matter if this A was in one place and all of a sudden the next possibility is this A is in the other place and they switch. that doesn't matter in this case. So we have to be careful of that. So normally when we want to talk about rearranging all the letters, once again, 4 factorial. But since the A itself, the rearrangement of the A doesn't matter, we have to get rid of counting extra. In this case, the 2 factorial. The 2 way to basically recombine the A's, right, in different ways. We have to get rid of that. So in this case, this is technically 4 times 3 times 2 times 1. The bottom is just 2 times 1. These guys cancel, right? The 2's and the 1's. 1's doesn't really cancel. But basically, you have 12 right here, 4 times 3. Well, in this case, here we have 12. So it's actually 6 over 12, or 1 over 2, or, 0.5 or 50%. Right, and there you go. A slightly harder problem, just to give you a little taste that sometimes, even though you hear probability and hopefully the introduction of probability wasn't so bad, it can get complicated as problems get more and more, I guess you could say, tricky. All right, so there we have it. The most basic introduction of probability. Desired outcome over all possible outcome. That is it, plain and simple. Now, once again, don't just look at this video and be like, I got this, I'm gonna go and take a probability, I don't know, actuarial exam or whatsoever, and I feel like I'm gonna ace it. The concept is easy. The problem itself, what they expect of you, the ability to actually find the desired outcome without, making an error, or the possible outcome without making an error. That's what makes probability a little scary, a little more challenging. So hopefully this introduction is okay. Eventually we're probably going to go into something a little more in-depth, a little more complicated. But as of right now, you know probability, you know what they're talking about when they say the probability of something occurring. That's all it is, right? Thank you for watching this video. See you in the next one.